Okay, let's now configure the network load balancer. From here, I go to Load Balancers, Create, and in NLB, Create, I'll give it a name like NLB Lab. Will be exposed to the internet. Under Network Mapping, I choose the VPC and just availability zones A and B because that's where my targets are. Note that the IPv4 address is configured as assigned by AWS. This means that AWS will automatically assign an IP address to the network load balancer. If you have an elastic IP address associated with your account, you could also select it here. By doing so, you can provide it to your network load balancer. For now, we'll leave it at that. Under Security Groups, I will choose the one I created in a previous class and disable the default. Note that the load balancer security groups should allow you to communicate with registered targets on both the listening agent port and the health check port. Moving down to listeners and routing, we are going to create two listening agents, one for TCP port 21 and one for TCP port 80. For the first agent, I will set the protocol to TCP, the port number to 21, and configure it to forward to TG1 FTP. Next, I will add another listening agent, this time for TCP port 80, and forward it to TG2 HTTP. Once all this is done, we go through and create the load balancer. Let's see it from here. And now it's provisioning. I'm going to wait a couple of minutes and I'll come back here and continue the demonstration. Well, after a few minutes, I have my network load balancer provisioned. If I go to Resource Map, I have two listening agents, one on port 80 and the other on port 21, each one associated to a target group with its corresponding targets, in this case, EC2 instances. So, let's test that everything works correctly. I will go to the Details tab, copy the DNS name URL, and open it in the browser. And indeed, the web service is running. Now, one thing I've noticed and I couldn't find any explanation for in the AWS documentation is that if I constantly refresh, we don't see that it switches the request to the other deployed server as it does in previous classes when the NLB was deployed. This has to do with stickiness. Stickiness allows to bind a user session to a server so that when the same user requests again, it is served by the same server. Even if you have not enabled stickiness in this load balancer, new requests are still synced to the same server, but after a few seconds, the request is forwarded to the other server, so it is still working correctly even if you cannot see it on the screen at the moment. You can replicate it if you leave it a few more minutes, and you will notice that it forwards the request to the other server. Now, let's test the FTP connection. From my terminal, I go to type FTP and paste the URL, and we see that it is serving FTP. However, there is also the issue of stickiness. If I disconnect and we send the request several times, I see that it connects to the same server, but if I wait a few minutes, we can now see that the request is handled by the other server. So, this is how the network load balancer is configured. The important thing here is that it allows you to load balance using transport layer protocols such as TCP and UDP. So, we conclude with this demo, and don't forget to remove your lab environment, including the NLB, target groups, and EC2 instances.